All right. First set of notes for the semester, coevolution of Earth. How has life on planet Earth changed the planet through geologic time? So again, set these up for Cornell notes with the margin on the left-hand side and the title with the essential question. If you do need more Cornell note template sheets, I believe some more, there's still some left in the book room. All right, so we're going to go ahead and talk about coevolution of Earth, how life and Earth have changed together over time, right? So obviously, I talked a little bit about this, a lot of, as far as how life would never evolve if Earth didn't evolve. So we're going to be talking about two different types of Earth, right? The physical Earth and the living Earth, right? So the physical Earth contains wind, the crust or rocks, water, and ice, and temperature. If also life on Earth includes plants, animals, bacteria, and fungi. And the physical Earth will also include the atmosphere, like the amount of carbon dioxide, amount of oxygen, and so on. And so anything that's living or once living is considered life on Earth. So we're going to be taking a journey through the history of Earth, similar to what you did in the simulation, but we're going to go ahead and talk about causes and effects. So if you have a highlighter, it could be a yellow highlighter and a pink highlighter. I was going to suggest a yellow pencil, but those don't come out very well. But some way that you can identify causes and effect. And a suggestion for yellow and red, if you don't have those two colors, you can take something else. Just make sure that you have a key saying, okay, these are my causes and these are my effects. So the first thing we're going to talk about is, how Earth formed. So 4.5 billion years ago, gravity gravity is the cause, right? Gravity caused the Earth to bring the chunks of rock and ice together, and that created the molten Earth. All right, so gravity is the cause, creating the molten Earth is the effect. So there was no solid crust. And then about 100 million years later, the cause was the large chunks of rock. The large chunks of the crust began to form. I'm sorry. So I keep on having to remember which ones the yellow is cause. So the cause is the cooling of the Earth. And then the effect is the formation of the solid crust, right? So cooling is the cause. I'm sorry about that. And then the crust forming is the effect. 4.4 billion years ago, all right? So the cause, we have the meteors and comets crash into the Earth. And since they were made of ice, they brought the effect is water. Okay. And then as the Earth cools, so the cause, we have liquid water. So Earth starting to cool causes the water to condense. And then we have the continued effect would be a shallow sea. All right, it may have volcanic islands, but for the most part, we have shallow seas. So 3.9 billion years ago, our stromatolites, these are actually still in existence in, I think, Australia. So the cause is the bacteria, photosynthetic bacteria, and the effect is oxygen in the oceans and the atmosphere. So the cause is a photosynthetic bacteria. The effect is oxygen in the oceans and the atmosphere. All right, so this is just a reminder that oxygen is a byproduct of photosynthesis. All right, so that's the most important, sort of tying it back to before, all right? they release oxygen as a byproduct. All right, so 3.5 billion, we have early free oxygen, because part of the simulation and the oxygenation of the Earth, the first oxygen was used, it was oxidized by the iron. And then so we started getting free oxygen in the atmosphere. So the cause is that photosynthesis, and then the effect is the absorption by the ocean and sea rocks. The early atmosphere was mostly made of carbon dioxide, methane, and other gases. Okay, 2.4 billion years, we have the great oxidation event. All right. Causes that we had to increase oxygen bonded with the iron, which formed rust. And then the extra oxygen that wasn't bonded to the iron filled the atmosphere. So, so this is the cause, extra oxygen, and then the iron filled the atmosphere. The extra oxygen, the oxygen that wasn't bound to the iron filled the atmosphere. Okay, 2 billion years ago, we have our ozone layer. So the cause is we have a lot of oxygen in the atmosphere, and that caused the oxygen to break apart. The ultra UV rays break apart the oxygen and form an O3 molecule, which is the ozone layer. All right, so we have a lot of amount of oxygen. The UV rays break the O2 apart into single oxygens, and they bind with other oxygen O2s, and they form ozone. Okay, the cause is the layer protects the Earth from the harmful UV rays, and the effect is now we have bacteria able to survive outside of the ocean. All right. 710 million, so the Earth cools. So we have the cause is extra oxygen in the atmosphere. The effect is the Earth cooling. All right, and then another cause is that since there's less oxygen, oxygen reduce the amount of greenhouse gases. So the effect is it gets a lot colder, right? So the the ozone layer and the carbon dioxide is a greenhouse gas, but if there's oxygen is not a greenhouse gas, so it produces a lot colder temperatures. And that's why we have the snowball Earth and mass extinctions. All right, so now we have 540 million years ago, the Cambrian explosion, first complex life. The extinction is the cause, and anytime that you have an extinction, it allows for other organisms to evolve rapidly. And you'll see that a few times throughout Earth's history. So our cause is that now that we have protection in the atmosphere with the ozone layer, we have the less harmful UV rays, we're starting to see more life on land. Okay, so since there's more ozone in the atmosphere, we're going to have land plants, insects, and animals on land, and then because it protects that UV light. No, just plate tectonics. We're talking about Pangea forming 300 million years ago. 65 million years ago, a large meteor hits Earth. The cause increases the carbon dioxide content in the atmosphere, and that causes our dinosaur extinction. And this is the crater in Mexico, the Gulf of Mexico, I believe. Or not the Gulf of it, but right outside of Baja. And then that extinction of the dinosaurs allows mammals to take over. All right, so 2 million years ago, the extinction, the cause is the extinction of dinosaurs, and then the effect is mammals to take over. And evidence of support this, we have ice core samples, seafloor sediment samples, fossil records, and radioactive decay in Earth. So fossil, so this is fossil, well, age, we can do this with both the ice core samples and rock samples. This is what we call relative dating. Lower down, the organisms are older than the ones above, right? Age is determined based on the order of the layers. The further down, the older the organism. Ice core, we can use this for gases that existed. So this is how we get the carbon dioxide levels are used to determine atmospheric conditions over time, so that you can see these little striations. They can measure the gas, and you can see it's up to 1.5 million years. Okay, so not too a long time, but we can see others. Seafloor is the same type of thing with as the ice core, although we can look at climate change, ocean circulation, temperatures, things like that. And that's up to 340 million years ago. Fossils in the sedimentary rock, again, back to that relative dating, but we do also have other dating. We don't have carbon dating because carbon doesn't go back this far, but we have other elements that we can radioactively determine how old. So, 3.8 billion years ago. All right. And so you can see the fossils in here. The fossils. Okay, so, and they do that by, obviously, like I said, not by carbon, because carbon has a relatively short half-life, but they can do it from, they can do it by other types of elements that have a longer half-life. Okay, so those are the notes.